Golang Interval Map, efficient lookup for timestamp ranges like Postgres tstzrange. Introduction. When caching data indexed by timestamp ranges, the common Go map falls short because its keys must be comparable types like int or string. What if you want to look up by a timestamp that falls within a dynamic range, example, a start and end timestamp? This problem is analogous to Postgres' tstzrange with the contains operator, which efficiently finds rows where a timestamp falls inside a timestamp without time zone range. The problem: you want to cache values by intervals, start to end timestamps. Lookup by any timestamp returns the value whose interval contains it. Common naive approach: create a map entry for each truncated timestamp, example, per minute, which causes huge redundancy and memory overhead. Using the lower bound as a key only helps partial lookups and can't find intervals containing the timestamp due to overlapping ranges. Efficient solution: interval tree in Go. An interval tree is a data structure designed for querying all intervals that overlap a specific point or range efficiently. Why use an interval tree? Stores intervals as nodes with start/end boundaries. Supports fast insertion. Finds intervals containing a timestamp in O, log n, time. Handles overlapping intervals correctly without redundant storage. Implementation overview. Define a time range struct with start and end, in 64 timestamps. Build a binary search tree, interval node, ordered by interval start. Keep track of the subtree's maximum end boundary for effective pruning during search. Core operations. Insert, start, end, value adds a new interval with an associated value. Find, timestamp queries to find the value where the timestamp lies inside an interval. Key code snippet. Refer to the detailed code snippet below. Usage example. Benefits. Memory efficient, no redundant keys for every single minute. Fast lookups, O, log n, query time via tree traversal. Flexible, supports arbitrary overlapping intervals. Simple API, insert intervals and query by timestamp. Conclusion. For Golang programs needing to mimic Postgres' tstzrange containment lookups, an interval tree implementation is ideal. It bridges the gap where a Go map cannot efficiently handle non-comparable interval keys. This approach is clean, performant, and scalable for caching or indexing time range data. Complete interval tree implementation in Go.